Hi, our question is today based on vectors. In this question, we have a triangle OAB. The point C lies on AB, where AC is to CB is 2:1. AC is to CB is 2:1. And OB is produced to D. OB produced to D, where OB is to BD is 3:2. So we got OB 3, BD 2. Now we need, because the vector OA is equal to vector A, vector OB is equal to vector B as been given, OA, this whole vector here is A, and this whole vector here is B. O to B is B. We need to find the vector AB. Okay, let's move on and find vector AB. We know from geometry of vectors that AB is equal to AO plus OB, always, right? So that's going to be vector B minus vector A, because AO is minus A. So the first part is done. Moving on to the second part, we need to find the vector AC. So this is A to C. From A to C, you're going to move from A to O, and then O to C. Now, how are we going to find the vector AC? Because we don't know this part here. So what we know is that AC to CB is 2:1. Therefore, AC is 2 over, let us say, AB. So AB is 2 plus 1 is 3. So that means the vector AC is 2/3 the vector AB. The AB can go there and get multiplied. So we have 2/3 vector AB, which is B minus A, and that was just found. So this is vector AC. Also, we need to find the vector O to C. Now the vector O to C is going to be equal OA plus AC. So OA plus AC. That means the vector A plus the vector AC, and AC was found to be 2/3 B minus 2/3 A. So we have A minus 2/3 A, which is 1/3 vector A plus the 2/3 vector B. So that's our vector OC. Done. We need to find the vector OD. Okay, for the fourth part, the vector OD is going to be equal to, now we know that OB is to BD is 3:2. So OD is then 3 plus 2, which is 5. Okay, over, let's do it this way. So if we want to find the vector OD, what we can do, we can find OB is to OD. So OB over OD is equal to 3 over 5. OB is 3 and OD is 5. We want OD. So OD is going to equal, you can send OD on the other side, and then the 5 goes there, so that's 5 vector OB, and the 3 comes down here, becomes divide. So we got 5 over 3 vector B. So that's the vector OD. We need to show that the vector CD is B minus 1/3 A. So this is part B of the question. The vector CD should be equal to, this is CD. We can find CD by taking CO plus OD. So CO plus OD. And if we take CO, right, now do we know OC? Yes. So CO is the negative of that. So that's going to be minus 1/3 vector A minus 2/3 vector B. Then plus OD. And OD was found to be 5 over 3 vector B. 5 over 3 vector B. Right, so let's do it that way. So then get C is going to equal to. Now we've got minus 1/3 vector A over here. What about this one? 5 over 3 minus 2 over 3. That's 5 minus 2 is 3, and then we divide by 3. So 3 over 3 is 1. 1 times B is vector B. So we got vector B, and that's been shown. We were told to show that it's going to be equal to this. And here we are. B minus 130, B minus 130. E on OA such that OE is 5/9 OE. So OE is 5/9 vector A. Express ED as simply as possible. We need to express the vector ED. Now, how can we find ED? Let me just go here. So ED, sorry, down here. Yeah, so ED is equal to EO plus OD. So EO plus OD. And we have vector EO because we know OE is 5 over 9. So EO is the negative of that vector. So we're going to say negative 5 over 9 vector A plus OD, and OD is found, here we go, 5 over 3 vector B. So 5 over 3 vector B. I can probably take the 5 over 3 outside if I want. 5 over 3 outside, and inside I'm left with B minus 1 over 3 vector A. How? B times 5 over 3, 5 over 3B. Minus 1/3 times 5 over 3 is minus 5 over 9, vector A and vector A. So this is the vector ED. Here we are. That's okay now. Then, for D, show that ED is equal to KCD, where K is a constant. Now, ED, we need to show that ED is equal to some constant K times CD. In other words, we want to find the constant K. So K is going to equal ED divided by CD. If we take ED, this is ED, 5 over 3 into B minus 1/3 vector A, all divided by, if you want, okay, CD. And CD was found to be B minus 1/3 A. So we got B minus 1/3, vector B minus 1/3 vector A. This is over 1, of course. You can cross these out, and you've got K is equal to 5 over 3. So in other words, we're saying that ED is equal to 5 over 3, okay, the vector CD, and that's been shown. Some constant, alright, which is a fraction here. Second part, write down two facts about the vectors C and D. So CD and ED. Now can we look carefully? If we see that CD is, where is it? Yeah, CD. B minus 1/3 vector A, and also ED, alright, because they're telling us CD and ED, look at ED, B minus 1/3 A. So CD and ED are in the same direction. That's the first fact. And because ED is equal to 5 over 3 vector CD, it's a fraction of that vector. It means that all these points, they lie on a straight line. And you can just say that E, C and D lie on a straight line. But if you want to be really mathematical, you can say the second fact is that C, E and D are collinear points, meaning that they lie on a straight line. There we go. These are the two facts. Now for the last part of the question, we want to calculate the area of AEC over OEC. So let's take a triangle outside here, on E. Okay, so I've got something like this here. We want to find AEC over OEC, so the fraction of these triangles. The thing that we look at when we have a situation. Now, first of all, before we conclude to anything, these are not similar triangles, all right? And if you look at OE, it was given here. OE is 5 over 9A. So the whole thing is 9. So we got OE as 5. So this is 5. Okay, and this one here, maybe it's like this. I want to be more precise. This is EA, and this one is 4. 4 plus 5 is 9. You see what I mean? Now, therefore, the area of triangle AEC over OEC, triangle AEC over triangle OEC, alright, OEC. So this is OEC, and it's going to be equal to 5, and this is 4. So 4 over 5, so that's the answer. Or you can say